Okay, let's look at section 4.10. And in this section, they just start with, remember the quadratic formula. Okay, so they don't make us derive it or anything like that. But if we have an equation of the form ax squared plus bx plus c equals 0, then x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And then x is real numbers if and only if our discriminant b squared minus 4ac is greater than or equal to 0. Okay, so we have that. Then they what they want us to do is be able to, take a circle and a straight line like that and be able to find points of intersection now. So that's going to be the applications they tend to give us. We could also do, two circles. That would also yield a quadratic, a couple quadratic equations, and it would yield a couple of them, and then we would use the two of them together to solve and go with that. But I think their applications are all going to be this first one with a straight line. Now, certainly their application that they give us in example 4.10.2 is just that. So they set up this situation with x and y here. They have a circle, radius 1, that's an irrigated field. They're going to fly over it in a straight line starting here somewhere. They're going to fly over this point Q that's right on the boundary, and in the way they drew their axes, right at the point -1, 0. So we know that point. What they're interested in is what's this other point if, where we're starting is 2 miles here and 1.5 miles here. Now, so I said that point is -1, 0. Well, this point then is 1.5 and -2. Okay, and so we can get the slope here. The slope, I'll take the -2 minus 0 over the 1.5 minus a -1, and that equals -2 over 2.5. Now, so I can write that as -4/5, or I could write it as -0.8. Okay, but then I take a point, I'll probably take that one, that'll be the easiest for me. And I have that y equals, and I'll go with the -4/5 times x minus a -1. And so that's -4/5 times x plus 1, or I could write it as -4/5 x minus 4/5. Okay, so there is the equation of my flight line. Okay, that's the model I have for that. And the circle, they told me had center 0, 0 and radius 1. And so I know that is x squared plus y squared equals 1. And so I also have y equals -4/5 x minus 4/5. And with that equation, what I can do is substitute my y in there to solve these two simultaneous equations for x. So I'll write x squared plus negative 4/5 x minus 4/5 squared equals 1. Now actually, I prefer sort of thinking of that this way, factoring out that negative 4/5, because then I'll get x squared plus, I can write this as 4/5 squared. Now notice I got rid of the negative because if I square it, the negative disappears. But then I'm left with the x plus 1 on the inside, squared equals 1. And so I get x squared plus 4/5 squared times x squared plus 2x plus 1. See, that was much easier to square that way, equals 1. But now I still have to kind of put all this stuff together. Well, so what I could do to make my life a little easier, take a couple more steps. 16 over 25, oops, this is plus, x squared plus 2x plus 1 equals 1. Now I'm going to multiply through both sides by 25. That gives me 25x squared plus 16 times x squared plus 2x plus 1 equals 25. But now I don't have to deal with fractions. So I've got 25x squared plus 16x squared plus 32x plus 16 equals 25. Putting everything together, collecting like terms, I get 41x squared plus 32x minus 9 equals 0. So there is my equation involving x. Now I can use the quadratic formula and write that x is equal to minus 32 plus or minus the square root of 32 squared minus 4 times 41 times negative 9, and then all divided by 2 times 41. Now, again, my life becomes much easier if I don't try to put together numbers real soon, because what I see is there's a 2. Well, that's divisible by 2. Well, 4 here is under the square root, so if I take the square root of 4, I get a 2. So this term is divisible by 2. And certainly 32 squared is divisible by 2 if 32 is divisible by 2. Actually I need 4 because I need to take 4 out of the square root. So this is minus 16 times 2, plus or minus. And I'll take a little extra step than I would normally take, I guess, but I'll write this as 4 times 16 squared. Okay, so I took a 2 out of each of the 32s and made a 4. And I had 16 left, but it's squared. And then minus 4 times 41 times minus 9. All divided by 2 times 41. Well, see now, when I take out that square root of 4, I got plus or minus the square root of 4. I've got the 16 squared left, but I actually happen to know what that is. And then I've got a minus and a minus, so I've got a plus 9 times 41. And I know what that is. And I've got 2 times 41 on the bottom. But see now, that's 2, so I get rid of that with that and that. So I could factor out a 2 out of both the top parts and then cancel that 2 I factored out with the 2 on the bottom. And so I get minus 16 plus or minus the square root of 256 plus 369. See, I could do that one also. all divided by 41. So this is equal to minus 16 plus or minus the square root. If I add this together, I get 625 over 41. Now, that's magic in that I actually know that 625 is a perfect square. This is minus 16 plus or minus, and this is 25. 25 squared is 625, so over 41. So finally, at this point, what we know is x is equal to minus 16 plus 25 over 41, or x is equal to minus 16 minus 25 over 41. And actually, I know I did this, well, I'm pretty darn sure I did this calculation correctly, not because of this one. I get 9 over 41. It could be right. Or I get x equals negative 41 over 41, which is negative 1. But see that, if I go all the way back up here, remember that was point Q there, x equal negative 1. So yeah, I'm really sure I did the calculations correctly. So I get x equals negative 1 for that one. That's the point Q. So this is the point I'm looking for with point P. But now I need the y value, okay? But I'll just use that straight line. I could use the circle as well, but I'm going to use the straight line here. And so that was 4/5 times x. Well, that's 9 over 41 plus 1. And so that's 41 over 41. So I get 4 over 5 times 50 over 41. And so as I look at this, this is almost equal to, oops, I forgot my negative on there. Gosh, I'm looking at, how could that be a positive number? Okay, negative, yeah, I had negative 4/5 times x plus 1. I take this 4/5 now, but notice, if I make that a 10 and that a 1, this is minus 40 over 41. It's almost negative 1. Okay, but this is my point Q. Q is 9 over 41 and minus 40 over 41. And at least relative to that picture that we had, it looks reasonable. I got a positive x value and a negative y value, and so that looks like I probably did okay. Okay, so I found that point Q, and that was, point P, sorry, P. And then it asks, how much time does the duster spend flying over the irrigated field? Well, I didn't write down that it is going at 120 miles per hour, okay? And so, though, at this point, you see it's just like our previous chapter, chapter 3. I have 2 points. Okay. So here was the point Q. Here was the point P. This was negative 1, 0. This is whatever I just said, 9 over 41, comma, minus 40 over 41. Those are the 2 points. And I know how fast I'm going. I'm flying this way at 120 miles per hour. Well, so there's a rate. I just need to know the distance, right? Because then I can get time is equal to distance divided by rate. So distance, I can get that, my distance is just equal to, using the distance formula, I have -1 minus 9 over 41 squared plus 0 minus a negative 40 over 41 squared. There's supposed to be 2 parentheses there. So this is equal to the square root of, now, so I have, again, the 41 over 41, so I'll get a 50 squared over 41 squared. So I drop the negatives at this point because I squared. And then plus 40 squared over 41 squared. Now the reason I did it this way is I'll write this as the square root of 50 squared plus 40 squared over the square root of 41 squared. And the reason I did that, well, I know the square root of 41 squared. Now 50 squared, well, except notice, and so I'm just kind of showing you some calculation techniques. Again, we can use a calculator, but hey, work on your arithmetic. It's a good thing. So you see I've got 5 squared times 10 squared plus 4 squared times 10 squared, all over 41. And so I can factor out the 10 squared. So I've got the square root of 10 squared times the square root of 5 squared plus 4 squared. Awesome. And that's all over 41. And so that becomes, well, the square root of 10 squared is 10. So I got 10 over 41, and then times this thing, which is 25 plus 16. Well, that's 41. So this is 10 times the square root of 41 over 41. And that is my distance. Okay, so again, that was the distance. And so that's in miles. Now, how big is that? Well, that would be 10 divided by the square root of 41. The square root of 41 is bigger than 6 and less than 7. So let's say it's about 6.5. So you've got 10 over 6.5, which is what, 1.5. So this is about 1.5 miles. And so if we want time, we take our distance over our rate. So we take our 10 times the square root of 41 over 41, all divided by 120. Now to check this, this is miles, and this is miles divided by hours. Well, the fractions would invert and multiply. The 120, we invert and multiply. And so we get 10 times the square root of 41 over 120 times 41. And that's hours when we invert and multiply up here. So, this is the square root of 41 over 12 times 41 hours. Now, that's actually not real helpful to me. Maybe I'd like this in minutes. Might be a little more helpful. So this is equal to the square root of 41 over 12 times 41 times hours times 60 minutes in 1 hour. We'll get rid of that. And whoops, I wrote 21 instead of 12. But 60 over 12 is 5. And so I get 5 times the square root of 41 over 41 minutes. And again, square root of 41 over 41 is 1 over the square root of 41. Square root of 41, somewhere between 6 and 7. And so this is a little bit less than 1 minute. Okay, now I'll look down here and see if they have a solution with numbers here. Yes, they say 47 seconds. Okay, so this is about 47 over 60 minutes. So about 47 seconds. And that looks about right to me, right? You know, because I said a little less than a minute. And back here, you know, where I said, well, it looks like about 1.5 miles, they said it was actually 1.562. Okay. So, so there we go. You know, there's an application, and let's see. Oh, yeah, and then they ask for, let's take a look at that. Let's look at how they get that. So this is a pretty big application. They ask for then, wow, you know, what's the closest distance here to here. Now, let me blow that all up and think about the logic we're using on that. Okay. Oh, come on. There we go. So, okay, again, here's our situation. You know, we have a line coming through like, well, sorry, I missed that. Try that. It goes more through like that. So let me get rid of that. Okay. So there's X, there's Y. Now, we want to know the closest we pass to the origin here with this line. And so actually what we want to do is find this intersection where this line, so I'll just call it some line L, is, I'm not sure why I made that darker. There, it's brighter again. L is perpendicular to flight path. You had to hear that from my dog, but so, you know, here's our flight path. Now, the reason I know it's perpendicular is actually, you know, think of a circle, right? Just touching this, and the radius of a circle is always perpendicular to this tangent to the circle. And, you know, so here's uniform distances around the center, and they just barely hit this line where it's tangent. So those should be perpendicular. If I move out this way, you see the line is longer. I've got a triangle, you know, if I blow that triangle up, right? I'm saying pick this distance here, not that distance, because if I go with the perpendicular distance, it's always the shorter leg of this right triangle. And so that's why I know it's perpendicular. Okay, so that line, the flight path line, we'll call it F, instead of Y now, I'll just call it F, was minus 4/5 times x plus 1. And so that means our line L would have to have a slope of 5/4 and a y-intercept of 0. And so my line L here is 5/4 x. So I used the perpendicular slope here, and then used the fact that I knew I was drawing it through the origin to get a y-intercept of 0. So that's my line L, and I can find where these two lines intersect by putting the y values equal to each other. And so I have minus 4/5 x minus 4/5 is equal to 5/4 x. Now again, probably the easiest way for me to handle this is multiply through both sides. Boy, my writing's terrible there. by 20 because that will clear all the denominators. So if I do that, I'll get a minus 16x minus 16 is equal to 25x here. So subtract 25 from both sides, 25x from both sides, I get minus 41x, and add 16 to both sides is equal to 16. So x is equal to negative 16 over 41. Well, that 41 keeps coming up a lot. Okay, so if that's x, then y is equal to, well, I'll use this one, the easy one, 5/4 x. So negative 16 over 41, and that's negative 80 over 164. Okay, so that point, the point of intersection, is negative 16 over 41 and 80 over 164, except, well, actually I can reduce that. I can divide everything by 4, top and bottom, so I'll get minus 20 over 41. So there's my point of intersection. And again, you know, from my picture, that looks right. It looks like I should get 2 negative coordinates, so I'm pretty happy with that. And then they ask, well, what's that distance from the origin to there, I think. Is that what they ask? Yeah. So they got that point, and they found then the distance. Well, since I'm going from 0 to 0, it's just the distance of 16 over 41 squared plus 20 over 41 squared, like that. And so that is the square root of 256 plus 400, all divided by 41, because again I have a common denominator of 41 squared. Take the square root of that, I get 41. So I have the square root of 656 over 41. And I don't know what that is. I know that, again, 625, the square root of 625 is 25. Okay, so this is some number bigger than 25 over 41. And, you know, 25 over 41 is, well, you know, if I multiply the bottom by 2.5, I get about 100. If I multiply the top then by 2.5, I get 62 and a half. You know, so my guess is, you know, this is a little bigger than 0.625. You know, probably around 0.65. But I'm wrong. It's 0.65. It's actually, according to them, 0.6263. Okay, so that's their distance. Okay, so I knew it was a little bigger than 0.65, but barely. Okay, so at any rate, you know, I was close. I would have thought a little bit bigger than this number, but you know, again, I would have been wrong. So yeah, I've been wrong many times before. So okay, so there's our distance, and that is 4.10.